Okay, so we're going to start a subunit of the waves unit that is specifically about light. So when you think about light, I want you to remember that it is a form of an electromagnetic wave, which means it has an electron that is vibrating, and that generates an electric wave. And that electric wave is going to thereby generate a perpendicular magnetic wave, thereby giving us the electromagnetic wave, as is implied by the name. Okay, so these light waves, um, you know, they travel at different speeds in different mediums, so let's actually make a note about that. So light waves travel at different speeds in different mediums. And sort of the speed limit of the universe is represented by variable c, which is the speed of light in a vacuum, which we've already addressed in the earlier portion of the unit. Oh no, I spelled vacuum wrong, right? VAC. Okay, forgive me. Speed of light in a vacuum, which is essentially the known speed limit of the universe. Okay, so we will always operate under the assumption that nothing's going to travel faster than the speed of light in a vacuum. A vacuum is just a region that is absent of all other molecules. Okay, it's totally void. So c is defined by this value, 3 times 10 to the 8 meters per second. And you can find this constant in your reference table. But I also want to point out that light doesn't only propagate through vacuums. In fact, light may not require a medium to travel through. However, it does travel through all different kinds of mediums. And depending on what light is traveling through will determine the nature of the way that light is going to bend. So we're going to talk a little bit about something called the index of refraction. And this means nothing to you yet. So the index of refraction is essentially a measure of how much a medium differs from a vacuum. Okay, so a measure of how much a medium differs from a vacuum in regards to its optical density. In other words, if a medium is more optically dense, it's going to result in the speed of light being substantially slower. Okay, so media with greater optical densities slow light down the most. Thus, causing the light to bend the most. Coming from an optically light medium. Okay, I'm just going to leave it at that for now. Okay, so the index of refraction, which is represented by variable n, is essentially a measure of how much a medium slows down light. So how much light has been slowed down relative to c, the speed limit of the universe. Okay, so that's another way to think of index of refraction. So index of refraction is a unitless measure. And by the way, refraction, which I'm going to get to more later, refraction is just the bending of light. As it is transmitted into a new medium. So the bending of light as it is transmitted to a new medium. Okay, so a higher index of refraction means that the light is going to bend more because it is going to be slowed down more. Okay. So actually we can calculate the index of refraction of a material using the formula N is equal to C over V. So as I said before, it is a ratio, really, or a comparison to how much light is being slowed down relative to C, the speed limit of the universe, right? So a higher index of refraction with a constant speed limit of the universe means that that medium is slowing down the light substantially relative to C. Okay, so for example, actually I'm going to show you some indices of refraction. They can be found on your reference table. I'm going to show you this list right here. So as you can see, air has an index of refraction of 1. So if n equals 1, but n is equal to c over v, then that means that the ratio between the speed of light in a vacuum and the speed of light in air, the ratio is 1. What that means is c equals v, meaning that the air is almost analogous to a vacuum. Okay, so let's make a note that air is analogous to a vacuum. And by the way, just want to point out, if c is the speed limit of the universe, so again, n equals c over v, if c is the speed limit of the universe, you're never going to have v be greater than c. So you will never have an index of refraction that is less than 1. Okay, so the index of refraction must always be greater than or equal to 1. So index of refraction is always greater than or equal to 1. Okay, so that is a rule of thumb because we know that c is the speed limit of the universe, 3 times 10 to the 8 meters per second. Okay, so now if we look at this list, if I were to ask you, okay, what medium is going to slow the light down the most, thereby bending it the most, we are looking for the medium that has the highest index of refraction. Well, look at this. Actually, it is a diamond. So diamonds are extremely optically dense. As a result of that, you get some really beautiful bending of light when you pass light through a diamond, which is why they're so appealing.